Hi, good evening and welcome everyone. Today we're going to look at the world of full stack development. I'm Subramanian and I'll be taking you through a journey on a quick primer on the world of full stack development. I have an experience of 18 years. I've been in the training, I've been into development, networking. I've worked right from Java. I've then moved on to the .NET platform, moved on to networking. I've worked in India and overseas, and a couple of nearly 15 companies I have consulted during my tenure. Let's go ahead and hope everybody can hear me and I'm loud and clear. So we are from Collabra, worldwide consulting and service providers. And we are also with Cognixia, which is a company coming under the banner of Collabra. We train more than 150,000 professionals across the globe, and we have 7,000 plus industry veterans. We have talent development in about 55 plus countries, and we are Cognitia from the Collabra group. We are training partner for Red Hat, Microsoft partner, ITIL, AWS, and we have certain awards and accreditations which are seen on the screen. So coming from my experience, I would start with my experience. In the year 1997, I started with Visual Basic. And by the time I learned Visual Basic, .NET came into the picture. Along with that, I started with C++ and Java, C++ data structures, Java, a bit of Unix, COM+. Now, the main reason to reiterate this point is as far as technology is concerned, nothing is really old. We take the same thing. Like if you look at machine learning and AI, it was the father of AI more early before 2019. In the previous century, it all started with AI, but it was not the right time for AI to really kick in, or the market was not ready to pick up AI. Then we moved on to the world of microservices, small services which are built, robotic process automation, Internet of Things, big data analytics, DevOps, cloud computing, cyber security, professional development, and BI technology. Now, this is the whole scope what we deliver. So coming back to my experience, C, C++, data structures and their relationships are still there. Data structures, principles, and practices is like we can always take up our previous experience, refactor them a little bit and adapt them to the changing world. So the world has changed a lot, and that from for the past 20 years, there are certain principles and practices which are carried forward. At the same time, technology changed, the way we do things changed, but data structures which were there for 20 years are still there. Certain data structures are there, algorithms are there, trees are there. So we need to adapt to all these changes with a common foundation. Now, the main reason I mentioned this is, as I mentioned, I started with C++ and core Java, then moved on to the .NET platform, moved on to Windows networking, where I was taking care of machines and right from installation till ghosting machines, all that was taken care. Now I'm going to relate this to the world of microservices, relate this to the world of full stack development, and why am I bringing this experience? So it relates, and microservices, we had services. We started with COM and COM plus. Right? We started with COM, we started with distributed computing. From there onward, Java became a network programming. We had EJB, we had servlets coming into the picture. It moved on. Spring framework came into the world to make enterprise development really, really easy. We had several frameworks which were kicking in right to the world now on cryptocurrencies, blockchain, machine language, AI, microservices. So there are many things which are really common to the entire journey, and there are a lot of new things which are happening in the space. So I start by telling this experience, which is going to connect with our session, like what are we going to do in this world with full stack development, and how are we going to bundle all these things together. So Collabra has centers of excellence on all these topics. Today we are going to dive deep into full stack development along with the world of microservices. So that was an introduction. Welcome to the primer on full stack development. There's a lot to talk about full stack development. What are we going to do in an hour? We're going to quickly take a 50,000 feet overview of what microservice development, what full stack development is all about, and the complete spectrum. And finally, we'll go through pictorial presentation where we would build a pictorial representation of how microservices and a front-end framework all falls into the picture of full stack development. Please send me a note if you are fine and we can go ahead. Now we'll go ahead with what is full stack all about? How is it going to help full stack developers? What are the things we can carry from our experience? That's very important, and how we can move ahead forward. Now coming down, I've tried to put everything together, which would give us a vision on what full stack development is about. Now, years back, 10 years back, we didn't hear about something called, let's say 20 years back, we didn't hear about something called Spring Boot or microservices or Spring Cloud. All we heard is Java. Now, yes, Java is still there, Java 8, Java 11, and Java started evolving further. And what happened is Java has grown up to such a level, like it has moved from a programming language to a network programming language to building enterprise applications and microservices. Now, these are a cloud of technologies which we're going to look at step by step and how everything relates to full stack development. Now, what is full stack development? That is kind of a term, very, very broad spectrum. We need to put our perspective in place. So putting it in a nutshell, full stack development, if I am a full stack developer, I should be able to build my applications. Let's say I build core Java applications. I'll be building my presentation layer. I'll be building my application layer. I'll also be building my data layer. So when it comes to presentation layer, earlier we were doing with the HTML, we were doing with servlets and JSP. So 5 years down the let's say 3 to 4 years down the line, I came into servlets and JSP. So Java, then went into network programming, then went into servlets and JSP. That was the old-fashioned way of building user interfaces. Right? And now we have frameworks like Angular, React, and Vue.js, right? Which are all used. Vue is a library, React is a library, Angular is a framework. So we have all these coming up to build very, very rich user interface, the presentation layer. Now coming to application layer, as I mentioned earlier, we used to have enterprise Java beans. Please spare me for the technical terms. How this is how the whole enterprise application development connects. We had enterprise Java beans, which was very, very hard. And that's where Spring Framework came into the picture and made enterprise application development very, very easy. Now this session is connected with Java technologies. So it's going to have a flavor of Java coming in. So we had Java and we built enterprise Java beans, which was very, very hard. We built monolithic applications, which were very big, and it worked during that time. But in today's requirement, where the market is changing rapidly, it's going to be hard. We don't have our own sweet time, like 6 months to a year to send a deployment or a product right every fortnight. That is once in 2 weeks. We need to do some deliverable, or at least in a month. So the business has changed a lot. Customers expectations have shot up very high, so the business requirements have changed, and definitely it's a way the IT industry moves, and then developers also need to update technologies. So through my experience, I always connect business with technology, and I would relate how it is in the scope later when we see domain driven design and how it helps a full stack developer. So this session is really targeted as getting a complete picture of full stack, and then if you're looking at moving on to onto full stack, it would guide you on what to choose and how to move ahead with this. Now we built applications. So as I said, EJB. So full stack developer now does not do EJB. He does application building with Spring Boot. Spring Boot is your Spring framework or rapid. Spring Boot helps build Spring applications rapidly. So for those who are new to Spring framework, Spring framework is a framework used for building enterprise level applications, and all the big giants are using Spring framework. So I would say, like, rather than saying these are the companies using Spring framework, it's easier to list, way easier to list out companies which may not Spring framework, although it's hard to find. So from a Java developer moving to JSP and servlets, moving to Spring and coming to Spring Boot is my journey. and still Java is the same. You can keep upgrading on Java. So it's not when you hear the word called full stack development, uh, you throw away something which is old and something totally new. It is, I would say, a new way of doing things, maybe effectively, productively, and suiting the needs. So today, if we step into our desk, the company is looking at us delivering products very quickly and satisfying the customer. Java. So from Java, we moved to JSP and servlets. From JSP servlets, we had EJB2. Then we moved on to Spring. And finally, now we are in the world of Spring Boot, where we can build applications very quickly. Then coming to the application layer, we started writing business logic. As I said, EJB came in where we wrote complex business logic. And now you would have heard terms like message queuing, Apache, Kafka, right, which LinkedIn, which was used by LinkedIn, where they can process billions of messages with events. And we hear the word Apache, Kafka everywhere, messaging, message queuing, asynchronous messaging, synchronous processing, all that comes under the application layer. When coming to database, we were more onto relational. We were sticking onto relational for years. And now quickly to spin up some data, you have to put all your RDBMS in place and then create a database, create a table. It was kind of challenge to set up a complete database and a table with all the rules and regulations to hold some data. So from there we came on to MongoDB, which is a NoSQL DB. You can store data as JSON files. It stores it as binary JSON, very, very easy to scale, light and weight, and it does not enforce constraints like how we had relational. So the change again here is from SQL, MySQL and Oracle. A full stack developer should also look at NoSQL databases. So he'll write an application which connects to SQL, as well as he'll also write an application which connects to NoSQL like MongoDB. So we've come all the way here, Java, Spring Boot. We've come to SQL databases and NoSQL database. So every application, what does not change, whether we are a full stack developer or whether we are a developer building an application, we would have all come across the presentation layer, application layer, and data layer. Full stack demands you to be a specialist in one. Maybe you may be a specialist in Kafka, but you would also know about the data layer and you would also know about the presentation layer. If maybe a team member who's doing the presentation is on leave on that day, you would be in a position to handle the presentation layer. Like when we say a full stack developer, it is end to end, it is expected. So ideally, although we don't do it practically, if a Mac is shipped to your home, you would be able to install your operating system, you'll be able to install all the software, set up your application, run it, and completely do it by yourself. So that is the real expectation of a full stack developer, where he needs to know an application from end to end, specialization in certain areas, and a general understanding of the other areas. We'll also talk about why, how it helps, and what is the real need. Coming down, we look at this. Earlier, we were building applications and deploying it into as desktop applications onto local computers. Then we came onto the world of servers, and now we are on the cloud, AWS, Google Cloud Platform, and we also have Microsoft Azure. So like startups who are building new products, they need not invest on the complete infrastructure. All they need to do is they can pay, get the service, and when business is up, they can automatically scale up the servers, the requirements. That is done by Amazon. Let's take AWS as context here. That is scaled up by Amazon. Amazon does everything, and when business is down or maybe the product doesn't go, your cost really comes down. So it's like pay, like how we have cabs today. We pay and we get the service. We don't need to buy a cab if you're just traveling out of station and traveling. Similarly, we can pay and deploy our application. Everything is taken by Amazon Web Services. So this really helps us focus on a business need rather than the IT and infrastructure around. Then coming down, we have cutting edge frameworks like Angular, libraries like React and Vue.js, which helps build very rich user interfaces for your mobile. If we say, like, if you look at many sites, Facebook uses React heavily. Google team in their products uses Angular. In fact, Angular was built as an in-house product for their products, and Google outsourced it, or maybe Google put it out to the whole world and let the world benefit. Similarly, React was also built for Facebook to internally drive their applications, and then it came out. We'll also be looking at many interesting applications like that when we come to the world of microservices. Netflix, we'll always come across Netflix. Netflix have pioneered in building microservices. So they have a lot of applications and frameworks which they have outsourced. So the general Java development community can start using it. So that is the world of full stack development. And then coming down to Docker, we'll do what is Docker. So I built an application using Java. Then I moved on to building servlets and JSP. Now I would build an application with a front end as Angular. So the presentation layer is not just with plain Java. So a developer who was doing Java development now has to know Angular to develop the front end. And a developer who was already traditional developer who did only Java and MySQL or Oracle now needs to do Java with, instead of MySQL, they should also know MongoDB. Java developer with front end using servlets and JSP, they would also do it with AngularJS. And there's another concept here, which is containerization. Docker comes in. Now, there was a very, very common problem, like the application runs in my machine. I am a developer. The application runs in my machine, but the application is not running on the testing server or the production server. So that was a real challenge. Now what happened is Docker containerization helped you put your application and bundle all the software required, put it inside a container like the shipping containers, and throw it onto any server and it would run. So Docker revolutionized the world and the way we deploy applications. And now we'll build our application. Let's say a full stack developer builds a Java application with front end like Angular, back end like MongoDB, and he loads his application along with the JVM and all the other runtime with MongoDB, everything into a Docker image. And he can take the Docker image and now host it on AWS. And so what does that mean? The way I started was building network applications using Java, which executed on the local computers to network computers. Now, me getting into Java development, I will be building Java applications as the backend with Spring Boot. I would be building Angular applications as the front end, which will run on the browser. Java will run on a JVM, and we'll have MongoDB, which is a NoSQL DB. Plus, I would also look at bundling my application into a Docker image, picking up my Docker image and loading into AWS. Now, in our team, especially the agile team, people would do different work. So there will be for sure specialized who are in AWS. There would be specialists on Docker. There would be specialists on Java. But as a full stack developer, I need to communicate and I have to have the bare minimal knowledge. I need to have minimal knowledge on how to deploy it on Docker and how to deploy it on AWS. So we would have heard the saying that jack of all trades and master of none. I would say we should step into the shoes of a jack of all trades, and we should also be a master at something and a jack of all trades. That is the combination which the full stack development world is looking for. So now let me connect back to my journey. I started on a computer with plain Java desktop applications, moved on to network applications. From there, moved on to cloud-based applications, and we built a front end using servlets and JSP. Now it is all Angular. We don't use much of JSPs now. It's Angular. Applications were all running in premises. They were all now deployed onto the cloud, and the cloud was set up with all the software requirements. Now the application is loaded into Docker and put onto the cloud. So as a full stack developer, I would be ready to work on Java, and I would also be ready to work or have the minimal understanding to work on along with the team who's doing the front end in Angular or React. I would be working with a team who's doing the deployment on the cloud. I will be working with a team who is containerizing the applications, and I would also be working along with MySQL relational database. I would also work with MongoDB, which is NoSQL or any NoSQL database. And I would be able to build different applications of different architectures. I was doing monolith, then I moved on to microservices. So we will be doing microservices, and we'll be using cloud modules, like how Netflix has used a lot of cloud modules. Those are the modules which run on the cloud. And finally, we'll be able to deploy these applications onto AWS, containerize them and deploy. Now, Git is also, as every full stack developer will know, Git is used for managing your source code. The entire source code built by developers are managed by Git. Now, as a Java full stack developer, there's a lot to load. You can load specific tools based on your project. But to put things in a nutshell, these are the key things which we need to know. So putting in, as a full stack developer, I would build applications with Java, front end which interact with front end in Angular. I would be working on frameworks like Spring Boot, building microservices applications and using Spring Cloud modules, deploying them on the cloud like AWS, Google Cloud Platform, or Azure. I would be able to work with relational and non-relational databases. I would be in a position to containerize my application and load it onto AWS. And I would work with other developers where we can put our code in a common repository. So the day one, when I enter into a team, I would know what are these tools, align with my team, and then start building my applications and also extend my support to the other parts. Now, when it comes to the other side, yes, we should be in a position to work on Windows, Mac, or Linux. So that is the real expectation of a full stack developer, meaning you develop an application from end to end, you specialize in certain areas, and you are able to provide support in the other areas. Please go ahead and type, since I would not be in a position to listen. I think everybody is on mute. Please type if you have any questions, please type them instantly. If all is well, type clear on the chat window. We'll move on to the next slide. Thanks, Gavri Shankar. So it's a very, it's a really a very big perspective, broad perspective. These are things which I have put on my experience. Plus, you can add networking. You need to know a little bit of everything and specialization in other aspects. Monolith versus microservices architecture. So we all do build monoliths. That is, monoliths are a single application where you bundle everything together. It's like one package, like a birthday cake. You can't break it down. So what happens is, if when you're carrying the birthday cake, if it drops, the complete cake becomes unusable. You can't make it in parts. And what happened is, we took a monolith, we put it inside a server. We need to replicate the whole infrastructure, multiple servers. Physically, we need to connect them with network. So monoliths are great. Still, monoliths work for traditional projects. But what happens now is, it's like saying you have monoliths are like aeroplanes. They can carry 300 passengers and above. But what if you want to go as a family, right? We need cars. So let's say you have an aeroplane, you have 300 seats, and let's say you have 30 30 cars with the 3 seats, right? Or you have 100 cars with 3 seats. So totally 300 people can get seated, and you can move the cars across the city wherever you like. Simple as that. So what I may say by a seat is one functionality. A monolith bundles, the aeroplane has 300 seats where everything is bundled. But in a car, you have 3 seats where you can put together. It has its own, it's completely can work on its own. We break down a monolith and we made lots of microservices. In today's world, microservices are very helpful. Now, there are many differences between monoliths and microservices. So as a full stack developer, you will be entering the world of microservices. Now let's match what we saw over here, ready to learn. We had a monolith written with, as I said, Java platform, and you may have the entire stack here. Let's say you write a microservice. Microservices are built by small teams, literally, let's say by agile teams. And like how Jeff Bezos has said, typically in an agile team, you should have only the number of people uh, who can feed on 2 pizzas, not more than that. So literally 4 to 6 members in an agile team. Each team will be building a microservice. So here, let's say we are building a banking application, the accounts, the transactions, the login, and reports, everything will be on the same, bundled into the same application. In microservices, we'll have account separate, login separately, login module, accounts module, transactions module, and we'll also have the reports module separately. Now the speciality comes in here of microservices. The first module, that's a login module, can be built with Java platform. The second module can be built with .NET platform, third with Python, and the fourth with JavaScript. And all these applications can interact with each other. So I would introduce the term called polyglot. Polyglot programming, meaning same application is written with different programs. So you may have one team specialized. So when we looked at this, let's say there is one team specialized in Angular. They may create a front-end module with Angular. They would have Node.js, like how we have Apache Tomcat. They'll load it on Node.js server, and they'll be using MongoDB. You may build your application with Java with MySQL and JDBC connection, or Spring and Hibernate. You may have this. Now, these applications can run on their own. They are isolated. They don't interfere with each other. They can be taken down, maintained separately, and that's how our whole application is built. So in traditional projects, we used to, if it is Java, only the Java platform uh, professionals related to the Java platform would be there. But now you may find a team who's working on Node.js and JavaScript, a team who's working on Java, another team working on .NET, and another team working on Python. And generally, we don't prefer multiple languages in the same project, but for sure, there would be a team building applications with Java and another team building applications with JavaScript. So here the picture is very really evident that we make smaller services which can run on their own. They can be deployed and they can run and they can be scaled on their own. Now, when we come to microservices architecture, it's a style of breaking down a single application and making a small suite of services. It's like monoliths are like an elephant, and let's take this analogy. Microservices are like ants. Now, what work an elephant does, maybe like let's say 1 million ants are going to do the same work. We have microservices, which is a set of small services, each running its own process and communicating with lightweight mechanisms like HTTP. Now, moving ahead, a team which builds microservice A can use MongoDB, and they can use JavaScript and deploy it into AWS. Team using microservice B can build it, deploy it onto Google Cloud Platform, may build it with Java, MySQL, and Java MySQL, and deploy it onto Google Cloud Platform. So we've really understood the real broad scope of when we enter into full stack development. What are the moving pictures? So it's really very different from monolithic to microservices architecture and how we build full stack. So now how do we relate full stack with microservices? Generally, traditional development used to be monolith, and full stack developers work on, many of the full stack developers work on microservice architecture. So it's like moving from being a traditional developer to full stack, movement from monolithic to microservices also accompanies the same transition. Next, now this is very important, and the services, earlier we used to be a technical team, we used to do the discussions and we used to build applications. Now that's no more the trend or the need. We need to be in close connect with the business team and really identify the business capabilities and then build our application. There is real transparency on what's going on in the application, right from the business analyst till the tester, business analyst, architects, tester. Everybody has the same understanding. Here, independently deployable. So as we mentioned, when you build a microservice, once you finish project A and when you move to project B, so in project A, I did Java with MySQL. In project B, I may be expected to work with Java and MongoDB. And project B may have AWS, project A may have GCP, project B may have Angular, project A may have React. So that is the big spectrum. So full stack is a very broad term where we can do as much as possible. There's always scope for extending into other areas. So we are also ready for multiple projects in the same agile environment. Next, each one runs in its own process, communicate with light mechanisms. They are independently deployable and we don't need centralized management. There would not be any shutdown or single point of failure. Let me bring a real world example. Netflix went down because of a missing semicolon in their code. It went down for hours and there was a great business loss. This happened. And that's the reason Netflix moved from microservices architecture to from monolithic architecture to microservices architecture. During that time, in the early times when Netflix was pioneering into microservices, they were using AWS and they found like they wanted some additional capabilities. They went in and created their own uh, modules, which are now used inside Spring Cloud. Netflix modules will come in Spring Cloud when we are building microservices. Now, what is the characteristics of microservices? Domain specific. Earlier, technical team used to have their own specification and documents. We used to get the requirements from the business team, and then we would do the UML design. We'd also do the object-oriented analysis and design. We'll have multiple technical documents, and these documents, for example, a class had its own. The technical team can decide on what to name the class and what to name the fields. But now it's no more like that. Everything is going to become domain specific. So for example, if we get into telecommunication, one company can say the plan which is given to the customer. The company may call it as plan, right? So let's say a telecom company A says like we offer different plans to customers. Telecom company B says we offer different packages to customers. So what we have to do is, when it is domain specific, we are forced or we are restricted to write the class name as package and plan. We shouldn't be changing it. So tomorrow, if somebody comes in the project and says like, what are the packages we can deliver to the customer? If the business team asks, the technical team also knows the word package and they use the particular domain terminology. That is very, very important over here. And that will come down to domain driven design. You start designing your application based on the domain. We would have all heard entities when we do Hibernate. Entities are used to map rows in the database, or maybe objects representing a row in the database. Now these are called as domain entities. So in telecom company A, if you look at the class, that will be plan, and in telecom company B, if you look at the class name, that will be package. That is domain specific. Multiple independent development teams, each team can work each by themselves, and how they can easily relate is they are going to use domain specific language. It's more of service based. You can always avail the servers. Loosely coupled, they are not tightly integrated. For example, one microservice can run in the US data centers, another microservice can run in Europe, maybe in London, the third one can run on Sydney. So they are loosely coupled and also in different locations, and they can connect with them easily. Fault tolerant, if one microservice fails, you always have another microservice responding, and we have continuous delivery. So day and night application is delivered, maintained, and we have new features getting added. Now I put this slide is very, very important, and I would like you to please go through domain driven design. This was a term coined by Eric Evans early. Now domain driven design is today's applications are very complex. If you come across a very complex project, you may look at them using domain-driven design. And this also connects with the world of microservices. So when we say domain-driven design, look at this, different teams are all building applications and continuously delivering. And the requirement is also continuously changing. We need faster time to market. When we talk about domain-driven design, this is a method of designing. It's not new, it has come way earlier. It's been used in some projects, but now it's gaining a lot of traction in the microservices world to make it easier. When we say domain-driven design, let's take an e-commerce domain. In an e-commerce domain, we find out the entities which are related to the domain, like product is a main entity, customer is a main entity. So we really look at more of the domain, like object oriented analysis and design, OAD. We look at objects and classes. Here we look at the domain. So if we take e-commerce site, you have an employee, sorry, you have a customer, you have a product, you have an offer. Now these are all taken as the domain models, and you will create subdomains. Now in a product, what do you have inside a product? Right, you can have like products which are like ebooks, products like which are going to be electronic products. So you take a particular domain, right? For example, the complete domain which deals with products, and then you can make subdomains out of it. Products provided by uh, the company, product provided by third-party vendors. So let's say product and vendors. You can put vendors as a separate domain, and you can put product as a domain. So isolate the complex system into different domains. From the domains, identify the different models, and from the models, make domain entities. We have in Java, we have done entities, sorry, we have done models. And after we do models, what did we do? When we did Hibernate, we went into entity models. Now we are one step ahead, which is called as a domain model. So when we say the domain model, that takes care of your domain. So when I say domain related to products, so the domain here is e-commerce, and the subdomains are products, offers, customers, and then we pick it up. So this kind of maps, and then we'll have what happens with products. All that comes into the subdomain. So domain is e-commerce, and we break it up into subdomains, and that is what is domain driven design. This is a more of an creative process, and it needs some practice to really design and find out the domains, not directly like what we generally do, like programming. That is domain modeling. And complex business logic is the purpose of domain driven design is to solve complex business logic. Now this is very important. What do you get? You get ubiquitous language. So when we say ubiquitous language, it is one language we need to coin. Like as I said, plan and package. It is one language. We make a dictionary out of it with the terminologies, and the entire team, right from the users, most probably we take it from the users or the stakeholders who are using the application. From them we take the requirements, we coin terminologies, the business analyst, the architect, the technical team, tester, developer, full stack developer, everybody has to use this ubiquitous language. So when you come to the world of microservices, since you understood like different teams are working and they're working independently, how come we have a structure of communication, or how come we have a structure to relate things? That is taken care by domain driven design, because each team will be using their own ubiquitous language, and so the team can completely work on their own, and everybody in the team understands the same language. It's like English now. We all have different regional languages, right? So what we do, we speak in English. Similarly, each team will come with a ubiquitous language which they can really use in their team, and that will actually map to technical team. So there's not going to be a problem in the technical team communicating easily with the business team, and the business team communicating with the technical team, because we will use we'll use the ubiquitous language. We'll not be using any other language which is specific to the technical team alone or some language which is specific to the business team alone. There is one language which you're going to use. And how is this language formed? It's formed by brainstorming sessions. During the requirement analysis, we need to really brainstorm and then get this ubiquitous language. So as a cutting edge full stack developer, if you go with domain driven design and if you go with microservices, and if you're ready with this set of ready to dive into any of these tools, platforms, libraries, and build microservices application, that would really be the goal. Now coming to Spring Boot. Spring Boot makes a build production Spring applications very, very easily and quickly. That is the importance of Spring Boot. I guess most of you would have worked on Spring and definitely migrated to Spring Boot. Let's move on next. Now, why do we need Spring Boot? So the world wants applications to be developed really quickly. We have an opinionated framework which helps us rapidly develop applications, ensures productivity, and it takes care of having the web server embedded in it, Tomcat. So you can take the application, Spring Boot application, and very easily in maybe in 15 minutes time, you can make a small application with the Spring Boot and Spring Cloud and deploy it on AWS. 15 minutes would be too short, in an hour, and you can show the whole world about a very, very simple calculator. So that's what Spring Boot helps you do. Very quickly develop applications, pack your applications, and you can just run them straight away. Next, we are having, these are all from the Spring portfolio or Spring ecosystem. This is Spring Boot. This is the logo for microservices. We build very small, self-contained, ready-to-run applications, bringing great flexibility and adding resilience to your code. Next, we like to load them onto Spring Cloud. On the cloud, if you need to use these applications on the cloud, you have Spring Cloud coming to your support, coming to the support. And there are many modules here. So what is needed when it comes to the world of microservices? Let's do a small workflow here. You have the browser, or you can have, let's say you can have a compute browser on a computer. Let's take a computer. You can have a computer, desktop browser. You can have a mobile phone or a smart TV. Let's take a mobile phone. We'll do a small workflow here. You have the browser, and you can build applications with the front-end applications like we saw. We can make an Angular front-end application, Angular, and this can be deployed onto a server, which is Node.js. You can use a database here like MongoDB. Let me put application here. So to run the Angular application, you can put it on a node server, and you can have a database like MongoDB. Let's take a database. You can have a database like, now you can bundle your entire application, the server, your application, and this, and put it inside a Docker container. Container and throw this onto the cloud, hosted on the cloud. So as a microservice developer, I would be using this whole stack. Now this is full stack here. Some of them call this as Java script full stack, right? Front end full stack, and the same full stack you put it on the cloud. Yeah, some teams relate this as full stack depending on what nature. So instead of Angular, we'll have Java, and here we'll have some server like Tomcat. We'll have a database like, let's say, MySQL database. and we can put it cloud you have, and tools like it. Now it depends. So if you do this thing over here in the front, this is going to be a full stack developer who is working on JavaScript full stack developer. This is a Java full stack developer. And now based on the context, you can also be a full stack developer who's working on this whole thing to the back. So now you have to really look at full stack developer, and the scope is very, very large. Now we have different applications accessing it. Let's say browser from a mobile or from a PC, you are accessing the application through a browser, through different browsers. Here we have the front end full stack developer. Now the people who develop these are front end full stack developers. People who develop the backend applications are backend full stack developers. This slide is related to microservices. So what are we trying to do in microservices? Now this may be a small service. One functionality is doing the login. Let's say this was a team who did the login functionality, and this is the team who did the accounts functionality. And now let's build this whole stack. With this whole stack and an agile team, we built two applications which are running on, let's say, two different clouds. And now these clouds, the applications on different clouds communicate with each other. They communicate. This could be AWS. This could be Azure. It could be anything. We deploy our application. We have several modules now. What is Netflix? So when we have these microservices, how does one microservice know another microservice? We have a registry, like how we search Google for different pages, information, and we find out new websites. Similarly, first component here is you have a discovery server. It's called as Eureka. We have a discovery server, and what does discovery server do is it registers multiple microservices. MS1, MS2, it's a very, very interesting world. Microservice 2 and Eureka server will register all these. All the microservices are registered, so other applications can look up these microservices. That is the Eureka server service registry, and the many products have come from Netflix and which is open sourced. Then we have routing, Zool, and load balancing. Now, if there are multiple microservices running microservice 1 and microservice 2, and there is a client, let's say we do a login, we would like to log in. Now, multiple customers will log in at the same time. Login 1 and login 2. We can say like login 1 can go to the login 1 microservice and login 2 can go to the second instance. This is going to be load balancing. Multiple microservices can be easily brought up and they can be easily shut down. And if there are more customers coming in, we can get more microservices. And when customers are not accessing it, we can shut down these microservices. So that's the world of Eureka server. And then we also seen client-side load balancing with drip and routing. We have for routing between the microservices, we have Zool. Now, Hystrix is like for fault tolerance. What happens in the world of microservices? Many microservices will interact with each other. Let's say MS1, we have MS2, multiple microservices. So let's say you have a login microservice or you do a transaction. Now, first transaction is checking your account. First microservice is checking your account balance and then doing the withdraw and depositing. And last microservice is doing a report or generating a bill for the transaction. Now, what happens in this case is if one transaction fails, so let's say this transaction failed, this one failed. Now, what happens in the whole chain? Let's take the third one failed. If the third one failed, how are we going to handle? The first microservice will be waiting for the second will be waiting for the third. We need to handle the faults. So there is a graceful way of handling fault tolerance, and that's where the histories module comes in. So we saw different modules here, Spring Cloud projects. We have Spring Cloud config, we have Spring Cloud sleuth. Spring Cloud config is like there are multiple instances. In this case, let's say multiple instances of the same login, same service for validating the login. You want to have a configuration. You can put the configuration on a separate server like Git, on Git based, a repository like Git, and then the configuration can be externalized and you can give it to multiple instances. So we can also store the configuration information externally for the world of microservices. Then Spring Cloud Sleuth, it is going to have distributed tracing. Now, as we said, you want a request. Request is going from service 1 to service 2 to service 3 to service 4. How do we trace this distributed? How do we trace the request across all the microservices? That is distributed tracing with Spring Cloud Sleuth. There are many modules which can also be used instead of Sleuth. This part. And we are nearly coming to the end, finally coming to the front end. Now this was for the backend. So as a backend developer, we've seen what is expected from us as a full stack developer. Getting into a team, analyzing, will it be Windows machine or Linux or Mac? We'll use different machines. Different databases are fine with us. Even different programming languages, polyglot programming languages. Then dev tools like Git and Jenkins at continuous integration, CI and CD. Microservices, if we are into a project which is all about domain driven design, we also have that. So from a big picture, a great full stack developer would be easily able to get into the project and start being productive from day one, upgrading on the skills which is required. So with this, we come to the final part. Yes, a backend developer who's on Java will now at times be required to learn the front end. So one great front end is Angular and React. Everybody's heard. You can build an application for the web, mobile, or native desktop using Angular. Angular is a product from Google. So we've seen a small workflow and everything required by a full stack developer, the expectations. So a full stack developer is way more than a developer with multiple stacks, and we've also seen like how to relate them together. As a full stack developer, you will be building complex enterprise application using microservices architecture, and I've added this so that it would be new to you. So if you can build the microservices with domain driven design, that is great. Build and deploy cloud-based applications, containerize the applications, and deploy Spring Boot applications to the cloud. This is what you can really look forward to. So in an hour, we've covered lots of ground, and I hope everybody has understood the scope of full stack development, and there are lots of opportunities in the industry. So let me say, like, I am very much competitive in the industry. If I can do this, if I can, I would say a full stack of full stacks right here, if you can. So I would say like all these products put together in a nutshell are to get started, and then you can vary according to the requirements of the projects. So to put in a nutshell, you can pick up Java 8, Java 11, pick up Spring Boot, build a microservice using Spring Cloud modules, use Git as a source code control, create a front end with Angular, React, whatever is your choice, containerize them with Docker, and work with SQL and NoSQL database, and you should be able to deploy them onto the cloud. Not a full-fledged deployment. You should be aware of how to deploy, or at least in case they want you to deploy an application, minimum level of. Thanks everyone, and hope this was useful. Yeah, have a great time. Thank you so much.